Welcome back. It's time for video 4, or a set of videos from Unit 3. We're going to switch our focus a bit as we begin this video, and instead of working on the exact answer, we're going to look at means for estimation. And again, I don't know that we quite do enough with this with our kids. Sometimes in math, that's really all we need, a good ballpark figure. And I think we could probably do a better job of having our kids develop these skills, but you kind of already heard it before. They'll develop them with us while we're in the room together. We need to make it a priority. We can't say, all right, when you guys go home tonight, think about these strategies. No, you have to do it when they're captive in your presence, and they will work at it with you. But they will go home and they will eat Cheerios and they will play Minecraft. That's what kids do, or they're going out and play some baseball. So let's get this PowerPoint rocking. Hold on tight. Here we go. Share. Here we go. All right, so you can see that on the front slide, looks like we're going to begin a change in focus, and we're going to go some estimation techniques. Okay, there we go. Okay, so now it's not the exact answer so much as a ballpark. And I think in mathematics, that's often what we need. When you go to the grocery store, you don't really worry about the exact total. You just want to make sure you've got enough of the green stuff in your wallet. I show my age. Everybody carries credit cards and Apple Pay. All right, but back in the day, we just wanted to make sure we had enough of the bills. All right, this is front end estimation. So you're going to add the 1 and the 3 and the 7, and they're in the hundreds location. So you guess it. That's looks like that's 11. So that's 11 in the hundreds location. All right. So far we've got an answer of about 1100. Okay, so base the place value back in there. Now, what do you got going, Dale? Well, I got a 27. Again, we did this compatible numbers. If I'm willing to make that 27 be about 30, and I could add that 30 and that 70, that'd be about another 100. So, okay, I've got my 1100 already on the front edge. There, I'm picking up another 100. So now you guessed that puts me up to 1200. And then I just have to say, well, I got that 38. Yeah, again, if you want, say, well, that's 38, but if we're estimating, that's about 40. So my sum, if I added all those, should be about 1240. How cool was that? So that's front end estimation, right? Not that hard. You and I have had the operations where 727's close to 30, 38's close to 40, and that's really all we're doing. We're encouraging kids to get numbers that are a little easier to deal with mentally. All right, grouping for nice numbers. Well, again, what do you got going here? If there are things that you can see that we could add together and maybe get something pretty, like maybe that 27, that's about a 30, and that 72 on the bottom, that's about a 70. They might be cool to add. So why don't we do that? If we add those, that's about 100. Now, this is a little sneaky because, you can do this with more than two in the group. So if you look at the other three numbers, the 39 is about 40, 38 is about 40, and the 17 is about 20. So we'll take all three of those babies, and that's about another 100. And that means our sum is about 200. So again, these are things we can do with kids. If we're in the room together working on these strategies, they will pick it up, but they're not going to go home and pick it up. These are things that you and I are going to have to spend some time. I think this one's a little less obvious, the idea of averages. All right, so if you look at those numbers, are all kind of clustered around an average of 3,000. And then you would say, well, how many numbers do you have? Well, it looks like I have 5 of them. So my sum would be 5 times what I believe that average to be, or 5 times 3,000. So we would have a sum of about 15,000. I don't think this one's as useful maybe as some of the others, but I'll throw it out there for you to look at. Probably a little less cumbersome if the numbers are smaller too. The idea of rounding, you and I have done this in the past, 4765, we probably would round up to something nice, maybe 5,000, maybe 4,800. All right, if you're going to go to nice numbers, make it 5, 30, 3154 at 3. So our sum's about 8,000. That, my friends, takes us to the setup for assignment A, for assignment 3A, problem sets from your book. You're going to grab your loose leaf or your plain white paper or whatever you got, and you're going to crank out some solutions. Send them to me as a PDF in the Dropbox, and I'll work at scoring them and getting results. So that wraps the content for assignment 3A. We're going to move into section 3.3 in this video, and we're going to begin our work on subtraction. All right, so that's the overview slide. We're going to look at, again, different models for using for subtraction. Most of us learn subtraction as takeaway, right? So we had a bunch of items on our desk and somebody said, I'm going to take away some of those items. And that's for most of us the introduction to the notion of subtraction as a takeaway kind of an idea. So here in the circle, you initially had 8 blocks and somebody's going to come up and take away 3 of them. And then again, probably by counting, you and I would see that we have 5 blocks left. So we have introduced the idea of subtraction with a very concrete model, the notion of there were 8 items there. Somebody came by and took 3 of them away. And the question says, how many of them are still left? And the answer is there are 5. You may remember we did the number line model for adding. We can use it for subtraction. The first 5 goes to the right, and then we're taking away 3. So the arrow that shows the displacement of 3 runs back in the original division direction of 0. So it doesn't go to the right. It now backs up. So that's 5 back up 3. And you guessed it, that would be 2. I like this one. This approaches subtraction kind of as a connection to addition. And I think it's something that we can do well with kids. If I ask you that we would like to have 8 things in that circle, and there are 3 already there, and then I can ask the kids, how many would I have to put in there? How many would I have to add to that circle, if you will, so that we get a total of 8 items? You and I know that the arithmetic involved is actually 8 minus 3. But here you're envisioning, what would I have to add to the 3 to generate the 8? And the correct answer is, you guessed it, we would have to add 5. Okay, so I like it in that it connects the 2 operations very well. It shows that one undoes the other. These are flip cards. And the challenge for us now is we would like to have 8 ladybugs, because apparently that's the optimum number of ladybugs. We don't have 8, we have 6. And so the question is, how many more ladybugs would we have to get up to that glorious amount of 8? And you guessed that we would have to have 2 more. So again, what you're seeing is the notion of subtraction very much connected to the operation of addition. And that's not a bad thing for the kids to see that one is a relative to the other. All right, for you and I to subtract, if A is bigger than B, the notion of A minus B says there is some unique whole number. All right, it's got to be a positive integer kind of guy, that we could add that number to B and it would match A. All right, other models for subtracting. This is the comparison. So Juan's got 8 blocks, Susan's got 3. And if they match them up, for every one that Susan has, we can match up with one of Juan's. We will realize that Juan's got some blocks that aren't matched up with Susan's. And you guessed it, the arithmetic indicated here seems to be 8 minus 3. And that's the extra 5 that Juan has that Susan doesn't have. All right, same model. This time it's circles, and you got Jean and Peter. Again, you pair up the ones they have in common, and you realize that Jean has 2 extras. So the math involved was once again a subtraction, 5 minus 3. That, my friends, will shut down video 4 for Unit 3. We'll be back shortly with our 5th and final video for Unit 3. See you then.